this video is going to be a very brief introduction on tension. Now, tension is a very important concept in physics, and it comes a lot in classical mechanics, basically. And so, normally, when you have anything like this, a ceiling, and you see let's say a pendulum attached, you would see there's one tension sign which goes up. Now, I'm going to be explaining what that actually is. Now, tension is nothing but force. I'll repeat that. Tension is nothing but force. Let's take an example. We have a ceiling over here, and we have a massless string. I'm going to be talking about that more in just a few minutes. A massless string, and we have a pendulum over here. So the pendulum is being attracted by some forces. Now, let's just list the forces. One force is mg, that is the gravitational attraction towards the earth. Let's say this is the earth, and yeah, this is just the surface, just an over exaggeration actually. And let's say this is mg over here. Now, if there's a force acting downwards on this ball, and the ball is still, there has to be some force which actually cancels this mg, and so we have to find out that force, and that force is tension. That force is tension. So we can say that the tension is acting in this direction. So tension is any force that cancels out the force of gravity, in this case, that is. So let's say we have another case over here with many strings. I'm going to be drawing the molecules as such. These are the molecules of the string, and let's say there's an object over here, object of mass m, and even this is attached to a ceiling. Now, when this is being attracted downwards, the objects also being the molecules are also being pulled downwards, so the space actually increases between them. But the molecules want to stay together because the string wants to remain intact, so the molecules apply another force upwards. So that is a kind of an electromagnetic force that the molecules apply to nullify the force or the effect of gravity. So there's a force that the molecules apply to stay intact in position, so that they remain close to each other and intact, and which that force is equal to mg, so that they cancel out the effect, and the string or the mass remains at the same equilibrium as it was earlier. So let's take one more case. I'll just erase this. And I'll choose a better color. Let's say we have an inclined plane. This is the inclined plane. That incline is not that good, but yeah, I think it do. And this is the angle theta, and also we have a pulley here. Let's draw the pulley with some other color. Say it's red. Alright, it's a good color. And there's one string over here attached to an object. This object is, let's say, A. This is object A, and there's another string which is going downwards. To object B. Now let's just take the case. Wait, let me just draw that in object B. Alright. So now let's take the case that the system is being accelerated in this direction. So that means the pulley is moving in this direction, so that this object goes down and this object comes back up. So what we do is, when we say that this is a massless string, what we mean is that the two tensions over here should be equal. So let me just take another case. I'll just explain this to you. If the tensions here are not equal, then the pulley will experience infinite acceleration. And let me just explain what I mean by that. If the tensions here are not equal, that is if we take the string to be massless and tension to be different, then there would be infinite acceleration. Let's just tell you what I mean by that. Now let's say we have two different tensions, T1 and T2. So, and this is being accelerated over here, so T2 is doing all the work. So T2 minus T1 is a force, and if mass is 0, this is 0 and this is acceleration. So now if this is 0 and this has a difference, so this way, let's take this as a constant x. T2 minus T1 is x. Therefore x by 0 is equal to a. That means there's infinite acceleration, which is impossible. So we have to take the tensions T2 is equal to T1 is equal to T equal. There are many cases when there are tensions which are unequal, and we require the uses of torques and all the other concepts of classical mechanics to solve those kinds of problems. So that is the reason why we actually take the tensions to be unequal and to be equal, sorry, so that there is no infinite acceleration, and the acceleration of this object is equal to the acceleration of this object, both in different direction. One is going over here and one will be going over here. So if this is mg, there'll be a tension to nullify the force, but this is already accelerating as ma. So by second law of the Newton's second law, it says that ma, the force which is acting downwards, would be greater by this mg, which is counteracted by this T1. So mg minus T1, and this is for object number B. And let's take another color for object number A, and that would be this direction of acceleration. That's this direction, it's going over there, and so T2 is going over this direction. And there's also we also have one force which we forgot, that is mg for A, mg. So what we do is we actually resolve these two components of mg. One would be in this direction, that will be mg cosine of theta, and one would be in this direction. Sorry, it actually became a bit big, it should be a bit small, it should come over here actually. Alright, so there will be mg sine of theta, and this is just the simple resolving of vectors. So what we see is that one component of gravity is acting in this direction and one component in this direction. So the component that affects this A is this component. This is the component that affects A. So we can, for A, what we can write is, let's see what we can write for A. MA is accelerating over there, and T2 is over there, and mg sine theta is over here. So you may have guessed it by now. We'll say that MA is equal to T2 minus mg sine of theta. That's because T2 is maximum over here as it's accelerating in that direction, and mg is over here and ma is also over there. So now we know that T2 is equal to T1. So if we are giving the masses of the two objects, we can calculate the accelerations and the tensions also. So that is the basic introduction of tension. I'll be posting some more questions. Let's take an example now. So we have a problem over here, a question in physics which is related to tension and a pulley, and it's a massless pulley. So it's a massless and a frictionless pulley, so we don't really need to concern ourselves with the fact that there's friction over there. Now the question says two masses 8 kg and 12 kg are connected at the two ends of a very light inextensible string that passes over a frictionless pulley. Find the acceleration and the tension. Alright, the spelling is wrong. Let's just cut that one I from here. Alright, so tension in the string when the masses are released. Now to understand the question, it is the best thing to do is to draw a diagram. Now let's take this as the pulley. Not a perfect circle, no problem. So not art, this is physics, this is fun. Alright, so this is a pulley, and the two strings over here, one in this direction, and let's say another one, we choose a different color, another one in this direction. And now there are two objects which are attached to it. Now let's take this to be a ball, and this to be this kind of an object, a square, a cubical shaped object. Now this has a mass of 8 kg and this has a mass of 12 kg. Alright, so now it is already understood. Now that if this is 12 kg and this is 8 kg, the object has to accelerate in this direction because this has greater mass and thus greater force, and therefore the gravitational force and the resultant of all these forces in this direction will result this object go in this direction and this object to go upwards. So let's say that this object accelerates with ma, and let's take this as m2a to draw the equation, to write the equations first, and m1. So this will be m2a, and the acceleration over here would be a2, but the force over here would be m1a. So instead of drawing a free body diagram, let's just understand this case. This object is going upwards and this object is going downwards. So it is understood that there has to be a tension over here because this object is being attracted by gravity, and that gravitational force of attraction would be m1 times g, and even this is attracted by gravity, and this would be m2 times g. So if this is moving upwards and this is moving downwards with the force of this, so that means this has a gravitational acceleration of m2g, and this has also got a tension. And we learned that tension have to be equal, because if they are not equal and this is a massless string, there would be infinite acceleration, which is impossible. So this is the system over here. Now let's take for object 1. For object 1, let me use a different color. This is becoming too bland now. Let's take which color shall we take? Let's take a blue. Blue will look good. Yeah. So we have for object 1. Object 1 is going upwards. So from Newton's second law of motion, m1a will be equal to T, there's a tension in the string, minus the force which is going downwards, which is opposite to the direction of tension. That's m1 times g. Awesome. So we got one equation. Now let's just fill up the values of m1. m1 is 8 kg. So 8a is equal to T minus 8g. Now let's come to object 2. Now for object 2, let's name this as the first equation. Having a bad throat, and this is the object 2. Alright, so object 2 is moving downwards. So from Newton's second law of motion, m2a is equal to m2g, because this is the force in this direction, and there's one opposite cancelling force which cannot actually cancel this because it's not in equilibrium and this is moving downwards. So that's why the tension has to be smaller than the m2g force. So minus T. So let's fill up the values here. It's 12a is equal to 12 times g minus T, and this would be our second equation. Now from the first and the second equation, we can calculate the values of a and T. Now g is, of course, we know it. Let's take it as, and well, let's assume that g is equal to 10 meter per second square. That's the gravitational acceleration in Earth, and this is just an approximation because it's actually 9.8 meter per second square. So let's say we have 8a is equal to T minus 8t, and 12a is equal to 120 minus T. Therefore from this equation, let's take the value of T as 120 minus 12a, and let's substitute the value over here in place of T. And how much would that be? Let's use brown for that. 8a is equal to 120 minus 12a minus 8t. Now 12a goes over there, so 20a is equal to 40, and therefore a is equal to 2 meter per second square. Awesome. So we got the acceleration. Now if we just put the acceleration in this equation, the acceleration is the same. So T is equal to 120 minus 12 into 2, and that's 24, which is equal to 96 newtons. There we have it. So we have acceleration as 2 meter per second square, and tension, which uses the unit of force, is 96 newtons. I'll be posting one animation now so that you get the concept right of tension and how it is actually used in classical mechanics. Thanks for watching.